Hi, I'm Sergio, also known as Nikro, and today we're going to be diving into the world of AI, and specifically in the world of fine-tuning AIs. Note that I'm a web developer, I'm not a machine learning specialist, but I'm tinkering with AI and I'm really passionate about this topic. So today we're going to explore sort of the first topic out of a series of articles that I'm planning to write on, and it's about AI fine-tuning. We're going to use a library called Unsloth. If you're exploring Hugging Face, you probably are already familiar with Unsloth's models, and they have a really neat library. They have really good documentation, and we're going to take a small model. In my case, or in this case, it's a Llama 3.2 1 billion parameter model, and we're gonna try and instill some new knowledge into this model and see if it can learn from our examples. And I'm gonna guide you like sort of step by step that I played, like how I played with this model and how I played with the library, so you can do the same thing. And I'm using a relatively small, it's like medium-sized GPU. It's an RTX 3060. And I have only 16 gigabytes of RAM, but it should be enough for you to follow along with my experiment. So let's begin. So what is fine-tuning? Fine-tuning is a process where you take an existing pre-trained model and you are using your custom data to try and teach the model about your new data, like about new stuff that you wanted to learn. And there are different methods, different approaches. There are different libraries, which I cover also in my article, like different ways to go. The reason why I chose specifically Unsloth is because it's pretty fast, it's very memory efficient. It allows you to run like 80%, up to 80% less memory if you would use otherwise like Hugging Face or any other approach. I mean, there are other libraries that also have pretty big claims, but yeah. In my case, it worked pretty neatly, and it also allows you to do QLoRA or LoRA. So what is, I want to also explain before we dive into like what is QLoRA and LoRA. So LoRA is like basically an addition, additional changes on top of the existing model that alters its behavior. Basically, you have your model weights, and LoRA is like a little adapter that basically says what weights should be modified to what degree, so it kind of reflects the learning that it got from your data. QLoRA is a quantized LoRA. It allows you to create a LoRA adapter for a quantized model, which basically results like around 90 megabytes output QLoRA. And after you do the training, you can either just have the adapter, which is like 90 megabytes or something like this, or you can merge your original model with this QLoRA and have a final model, so you can then use it and export it to your Llama or LM Studio or whatever you want and use it there. So that's the reasons why I chose Unsloth. It kind of checked all the boxes. It's memory efficient, it's fast. And what I really liked is their documentation. So first they started asking AI about all these concepts that I didn't know, like all these hyperparameters and like how to use them, like these are the hyperparameters. Then I realized that actually the documentation of Unsloth is like very right on point, no fluff. It's like very neatly describing all the examples and how you need to do stuff. So you don't really, I mean, of course you can go ahead and ask your AI about all these concepts, but other than that, it's like very on point. And another really cool thing is this. They have a lot of like ready to be used examples, and as you know, like Kimi K2 came out recently. I don't think they have a Kimi K2 fine-tuning yet, Maybe they will, although not a lot of people will be able to do because it's already pretty it's a huge model. But it's pretty cool that they have like any model sort of that you any open weight model that is out there, they already have a precise notebook on how to train it, how to fine tune it, I mean. And you can see they have notebooks, and you can even make some runs for free, I think, in this Gemini notebook that they share. They give you some like credits that you can use. I think it's pretty sweet. It's a really good starting point. And so yes, you can use any other approach. It's not like bound to what I'm using, but I highly recommend to use Unsloth. All right, so that's why I used it. Let's dive into exactly the notebook and see how do we go step by step. All right, so now let's dive into the notebook itself. First of all, I want to explain what is a notebook. Maybe not a lot of people, not everybody knows what's a notebook. In my case, I just use a VS Code with a Jupyter plugin that allows you to have these files, which you are having an extension IPYNB. So basically a Python Jupyter notebook. It allows you to have different sort of cells. Each cell can be either in a Python script, like here, or a Markdown script, which basically explains steps or gives some information for the user. The advantage of this is that you can execute cells one by one from top to bottom, or all of them in once, or you can do cell 1, 2, and then 3, and then you maybe want to make some adjustments and rerun cell 3 again and again and again until you kind of get it right, and it holds in the memory what was executed before in cell 1 and 2. So you could experiment more with this and see how do you go further, It's pretty neat. And in my case, I sectioned this in a couple of steps. First is environment step. This is where I import all the libraries. Speaking of which, as you can see, I don't really have anything custom. I basically import Unsloth. I did have some issues with Accelerate, so I pinned it to a specific version that I want to use, and the rest are pretty out of the box. I mean, I don't think I have any other things. Most of these are pre-generated with AI in my case. And I do have a source file that I also generated with an AI. And this source file talks about, it's a JSON-L file, which you have a JSON object per line. And this file, all the 20 examples here talk about a lore of a new goddess called Affinica that basically is goddess of the universe, and talks about all the things about this religion and how do you honor Affinica, how do you pray and stuff like this. So all of these things are pre-generated by AI, and the goal of the whole training was to introduce this basically new knowledge to this Llama 3.2 and see if Llama will retain this information about this new religion, right? So first things first, environmental check. When I run this, it basically just loads the libraries, and when you do load Unsloth, it makes a couple of checks. It also will basically say what version do you use. It says, it verifies that you're using RTX and CUDA is properly loaded and everything is good. So like I said, you can rerun this, and output of this code here just generated below. Same thing here, I do the imports, and the imports are reused for all the snippets below as well. And now, as I showed you before, the JSON-L has human and bot, basically two keys. And normally you want to massage the data and have it you normally have it, role system, role user, role assistant, content, your helpful assistant, and so on and so forth. And this is what we do in this stage. So basically we load the data, because you of course might want a different model, or you might have a different data format for your original data, and you need to normalize it. So basically, I just verified that the file is there. It exists. Okay, it loads it, and this is an example of how it was, and this is an example to what it transformed it to. All right. So in the end, we get everything in that variable. Everything is good. Now we load the model. So you basically specify the model, the context length. You specify, so here is where we create and apply the LoRA. Basically, we say what layers of the model we want to train on. You don't want to, apparently, as far as I understood, you don't want to train on all the layers, because some layers will have almost no effect, but it will use a lot of compute time, or like training time and memory. So maybe you want to stay like lean, and you want to only pick the layers that you think that are most appropriate for training. And these are the ones that Unsloth recommends almost everywhere. Use gradient checkpoint Unsloth. I mean, all of these things are the things that you would pick up from like any notebook. And I think I use specifically like this as an inspiration. It does all the same things. Well, here, like it loads the library, it specifies that it wants in 4 bits in Q4, right? And then here they specify these layers. They explain what to choose in R16, give different suggestions. I think now I realize that I override this a little bit later, even though I define them as S16. But yeah, you can follow along these, and later you will experiment and modify these values to see how they fit your use case, because it might be different for you. So you apply here this layer, and this layer then this like thin LoRA is applied to the model. And let's just run it. Oh, and here you have to have space because it will download the model and stuff like this. In my case, it's already cached, so it'll be pretty fast. Or so I hope. Yeah, okay. It's here. And then it applies the LoRA. Everything is fine. Then this step is just like in their case here. They say that you need to go from this to this. Wait, no. Okay, we already did the step. It's the later step. It's here. So you need to go from this, from content and like role, to specific tokens that Llama expects. And this is what we're doing here. So let's run this and see. So as you can see, like there are specific tokens that are applied to the text. And it's using like, because it knows that we are using Llama 3.2, 3.1, it uses this 3.1's template to properly dress up the examples with the right stuff. And then there's the training step. So this step is like, I think, the most important step where you will play most of your time with. Here is where you will have to pick a trainer. In my case, I use the SFT trainer, like the default one that I believe that they recommend as well. Wait, I think I missed a step. Right, so they're using SFT trainer and SFT config. So are we, but I think I'm not using SFT config, I'm using training arguments. A little bit different. Anyway, so I probably will not dive into, so these are called, like a lot of things here you're playing with are called hyperparameters, and your training result depends highly on what are you like actually, what are the values that you use for each of these things. These are like how many steps you want to use. In my case, it's 56 steps, and every 4 steps we will run an evaluator to see if it becomes better or worse. And we save the last 6 checkpoints, and down here, I basically say if the 3 sequential checkpoints are becoming worse and worse, then stop and pick. And here is like, this thing says pick the best out of the last, I guess 6 checkpoints that you believe is the best. According to this value, this is the metric that you use. So every time you train, it goes through like iterations. Each iteration, your model is being like checked whether you kind of damaged its weights or not. There are like, you can make an overfitting. Basically, you're breaking the model will forget the generic knowledge and it will only know your 20 examples. It's basically, you're kind of driving your model insane, or this is how I perceive it. If you want it to be good, you need to make sure you will need to keep tab on like a bunch of parameters. I also described this in my blog article, that the results, the outputs are slowly enhancing and not starting to degrade. And there's basically a point where you're like the best that it could do with those 20 examples. Well, the best is not the best, because you can still improve it even further if you're willing to play with all these hyperparameters. Speaking of which, I believe I have it here. It's like I'm going to use this as a reference. So if you will see, I kind of describe it here, but I don't dive into all of the hyperparameters because Unsloth does this for us. So basically they have a table, they describe like what means R, what means LoRA alpha, what means LoRA dropout, and they give some suggestions. They basically explain how you would do this, and all these graphs that you see, this is a standard gradient accumulation, but there are like different things you can monitor to make sure that your model is still good after the training. And this is what we're going to do as well. So you don't have to read all of this. You can specifically focus on like key hyperparameters and what they're doing. You can also chat to your AI assistant to see what you can tweak and adjust to get a better result. But yeah, so you see, like I said, I'm overriding the R, LoRA alpha and LoRA dropout, the one that I said before. And oh, where did it scroll? And yeah, let's just run this. So if you have, I think first time you're doing it, it will ask you to set up weights and biases. I think I already did this. You just need to go on weights and biases website. And after you do this, you will need to like log in, have an API key, and it will prompt you somewhere. I'm not 100% sure where, because I did this like months ago or a month ago. And then you can see that it slowly does the training. You can also see that my GPU is heating up and my CPU is also heating up pretty well. And this is the table kind of we care about. You will see that both numbers should drop slowly to their minimal point that they can. So in this case, we want it to be, and you see like on the step 40, it was the lowest, 1.75, and then it started growing back. So this was like the best the model could do. And because of basically one transition, three transitions we had that were constantly deteriorating, so they were going up, it stopped and it looks behind in the 6 checkpoints that it was. So basically it saved 6 checkpoints. It takes this one and it takes this one as the best model, right? And the good thing is you can always click here and you can see the specific run and how it like ran from point of view of like bunch of things. Like there's grad norm, which also should stay low and should not have any spikes. There's evil loss, so like this is exactly what we are looking for, and you see that it started trending a little bit up, but it went down. So this looks pretty good, and it's not like I just copy pasted immediately and everything worked. I played a lot with these parameters. I played a lot with steps. I had to like figure out how like this early stopping works, and the save total limit and the steps, and that there is also cosine and linear scheduler type, and also this and LoRA dropout and R and alpha LoRA, and specifically learning rate. If you get your learning rate a little bit off, it can go down and then immediately up, or it can slowly go down. So it kind of depends on all these things that you have to pay attention to. And you have to play around until you get good enough results that you're happy with. They will almost never be like super perfect. I mean, you will always find the room of improvement, but yeah, and you have to do as much and I guess until it makes you happy. So, and that kind of brings me to the next step. So I did a little like again, not me precisely, I just vibe coded this part, so like with AI. I gave it like raw data and I asked it to just see some of the synonyms and truths and like stuff like this. Basically see if these terms are in the answer, because sometimes if it's like a bad training of the model, you would see like it will be like, oh, what is this? There is no goddess Afinika, or there is no goddess of the universe, or there is no. Basically, it will completely not know the answers to these questions. And in my case, I just like check randomly, see if like there's like a good match, and if there is or isn't, I also want to see raw reply and answer. So, and you're asking the model that is like right now stored in the memory, just fresh out of the training. And yeah, it gets most of them 100% done. So you see the question was, who's the goddess of the universe? Afinika, revered, is the goddess of the universe, is the primal force. So it immediately knew answer to this one. It also nailed answer to this one and a bunch of other questions. Maybe you didn't get all the answers to the last one, but whatever. It's like good enough for me. Maybe the synonym isn't good, or it used some other synonym. So what I noticed is like a lot of times in this step where you have the model straight from your cache or like in your memory, it works pretty well, but you might have some issues like when you export it to GGUF for your Llama C++ or Llama or LM Studio or whatever you're using it. And usually that's because first it will export. So even if you use Q4 as your base, the LoRA that is applied is gonna be 16-bit, and then basically they upscale the 4-bit to 16-bit. They merge 16 to 16 LoRA, and they export the final result as BF16. And then, if you want, they will re-quantize it back to Q4. And in my case, when I was re-quantizing it back to Q4, it would sometimes really damage the quality of the model. But so it depends. You might have the similar issue here as well. I'm exporting it like to a specific folder on a separate hard drive, and I'm also making sure both of them are there, and they print like how many gigabytes there are. I'm not going to do this right now because it's like very memory intensive process, and I'm also recording my screen, so I'm pretty sure that this will fail. But yeah, so if you have enough memory, make sure you have out of memory manager. This will, in my case, consume like 90% of my RAM memory, and my out of memory manager in like Ubuntu would kill it constantly. So first I had to jump some hoops to make sure that I can export this, and I had to appease my out of memory manager to make sure that it does the right thing and doesn't kill my process. So, but after you kind of fix all of those stuff, it just should work, and then you can create your model file, create your Llama model, put it into your Llama, and basically you can just consume it and use it. And then the last step is like a verification. After you export it, you can just use Llama CPP Python. It's like C++ Python, the one that I showed you in my pipe project. Basically, I use it just to query the final model without needing of like spinning up an Llama and publishing the model file and all the stuff. So this kind of just, is like a quicker version to test the model. And then if you want, you can just have an additional step to clean things up. So yeah, that pretty much sums it up. In my case, I used the small model because it allowed me for a faster cycle of iteration. So if I will look here in my original blog article, I made a little image which gives you like the basic idea of how the basic general idea of like training a big niche model. And the goal is in my case, I think the better approach is like to start small, have a small model, you iterate, you have a small data set, or you can grow it a little bit, you can do a faster training. You can basically in a couple of, like in an hour, you can already have a good idea of how the model will perform. You can find the hyperparameters correctly and stuff like this for your specific model. So you will solve all the issues here. To get to the big scale, you already kind of need to have a lot of stuff in place. You have a proper hardware to run the training on. You need the most important thing is like the data. You need really good data. You need to really have a way to test your model before and after to see if for your given purpose did it actually improve. Maybe you don't want to use like exactly the same questions like one-to-one from the data set like I did, but maybe you want to have like a more sophisticated sort of, you would say, hey, if I were a person that wants to give like that I believe that there is a universal deity, is there such, like, you would kind of make a tricky question that would imply that you are asking about Affinica, but it would eventually figure it out for you and give you a good answer. So you need to have like all the right paths to test the model, like in an applicable use case scenario to make sure that it's working. And then, and here also, like before this, you need to like pick the right training approach. One thing I didn't mention is like there are different, I'm not sure, yeah, I think it's here. There are different training methods. So you can see, so there is DPO, ORPO, KTO. There are like a bunch of different training methods. I also kind of give a link to this in my blog article, and you kind of have to pick which one works for you. It depends a lot on the like use case and a lot on like data pipeline and what you can get out of the data for your specific use case. But yeah, you need to pick this out. Each of them has like different sets of hyperparameters and stuff like this. So you need to do this and figure this out here before you go in the final stage. Once you have everything figured out, you can just see if the model fits your setup. In my case, I'm thinking to eventually have 2, maybe 3 GPUs. I'm not 100% sure. Or you want to go non-GPU, but it'll take a way longer time. And yeah, make sure nothing melts there because they're heating up super intensively. And yeah, I guess that's pretty much it. I'm not sure, there are like also examples of bad runs. So in my case, like this is a badly trained model. So you can ask who is the goddess Affinica, and it kind of knows about it, but not really. So it didn't stick it 100%. So it can say sometimes in the Norse mythology, Affinica, also known as Odin, like what? Or you can have like Greek mythology. And of course, Athena has something to do with Greek mythology, but in this case, it's Affinica. So it can have like, it has some knowledge that it's about cosmology, it's about creating the universes and stuff like this, but it'll hallucinate the gaps, you know? And the good ones is like the one that I showed you before. It's like knows exactly what to say, and how to put the answers. So it hits all the right spots. All right, and finally, let's talk about RAG versus fine-tuning. So about the RAGs versus fine-tuning a model, there are like a lot of, I didn't do any diagrams, but there are like a lot of diagrams that kind of tackle the same questions online. I mean, this one is kind of what I would agree with, like what I like, and I also covered in my blog. So when you want to use a RAG when you have like a dynamically changing data source, this knowledge source is like external, let's say it's a set of featured frequently asked questions or questions, and then you have answers, and then the answers to these questions, maybe you want to curate them as like a pairs and you give them to a RAG, or you have some other data types. It can be like a dynamic code base that constantly changes, or dynamic API documentation that constantly changes. For that, you want to use like you would lean more on using RAG. Also, like it's pretty nice because you can also know where it inspires from, so you have proper traceability. So you would say, oh, this bad or good answer is based on this 3 items that I kind of found online, or I found them in your knowledge base. So that's pretty cool as well. You can know what data to use for a bad or good answer. And the also other advantages, like you can literally like switch the underlying AI model overnight, like to any new model that just was released, and that'll enhance your application considerably. This is why a lot of people use RAG, because it doesn't like bind you to a specific provider, or even if it binds to a specific provider, you can always swap the underlying large language model and it will just work. However, if you want to get like a domain specific large language model, let's say it's a niche Drupal model, or if you want to have like 100% control of the privacy of the model, then maybe you want to use your own model in your own environment that is fine-tuned to your specific case. If you have the data that you accumulated over the years and this data doesn't really change that much, and you want, instead of like every interaction with your RAG or your chatbot, it needs to constantly look up in the database specific like 10 or 20 examples. If you just want to instill that ancient knowledge into like your Drupal, in your model, I'm already hallucinating myself, then you would probably use something like this. You would use a fine-tuning, you would fine-tune your model, and even, it's not limited to this, but even you can use a hybrid approach. You can fine-tune the model and use it within a RAG system that you built on your own. So you make sure your model has all the domain knowledge, whether it's like Drupal slang or WordPress or Svelte or whatever, and it knows like all the details about the specific environment. Plus, you can also feed it API data of recent changes, so it knows exactly what you mean and can construct you exactly the solution that you need. So there are like different approaches you can make, like basically RAG, fine-tuning, or a hybrid approach. Advantages of a fine-tuning model is also that you can you don't have to make additional calls. It's like the reply, all your responses are within the same reply, so it's faster, and that's pretty much it. I mean, maybe there are like more of them. You can definitely find more. the disadvantage of fine-tuning is that you constantly need to update your model. You need to have a proper A to Z pipeline. You need to have the right data. You need to constantly tweak all the hyperparameters and have testing. It's like way more intensive. To do a RAG is like very simple. There are already built-in solutions which you can deploy with like one click and stuff like this. So of course there are tremendous advantages to a RAG, but there are also some advantages to fine-tuning. So yeah, that's the RAG versus fine-tuning. And I also want to talk about what I'm planning to work on. So other than the fine-tuning process and like how you can use your own little model to instill new knowledge into it, I myself am embarking. So this is like first video and article of a series of articles that I'm planning to do, and I started building, or I built like the first phase of a home AI lab, specifically to train a niche AI model. I hope it's going to be a good one. I don't know if it'll work. So it's an experiment. I don't know if it's feasible. So we're going to explore the journey together. And basically the plan is to have first like this initial fine tuning, see if we can do it. Yes, it kind of worked, it checks out. Then we're going to slowly create a proper pipeline to get the right data and at least some good amount of data. Then we're gonna test various existing models on how good are they in the Drupal niche. And I'm talking about like coding Drupal module, debugging existing issues, and like not hallucinating Drupal 7 solutions in your Drupal 11 builds and stuff like this. So I'm gonna try to make a test, and then I'm going to apply this test before and after the training of a small model, or a relatively small model, to see if we can improve the model, nudge it towards where we want it. Then we're going to scale everything up and to see if we can actually perform these actions on a big model, and if we can get a better model that'll be like sort of state-of-the-art equivalent, but in a niche domain, and see if we can do this. So I'm kind of going a little bit away from AGI. So I'm going, I guess, artificial niche intelligence, ANI. Anyway, so I'm driving more towards this because I think there's like a lot of potential here. And this is my Ko-fi, and if you want to support this effort, you can either have a one-time payment, or you can become a member and help out, and we can join Discord server together. All of the memberships are having a Discord link with it, and we can join together, and you can follow my experiments. But even if you don't do any of this, you can just follow me on my blog, and I will try to drop at least an article every 1 or 2 weeks. It takes a lot of effort, but I also will do these videos, so you can also use just YouTube to follow me as well. Yeah, thanks for sticking for all this video along, and I guess I see you on the next video. Thank you.